Welcome back, students. Our today's topic is wide band and narrow band pass filter. Last class we have seen what band pass filters are, right? So here we already know that band pass filter means a particular band of frequency will be passed, like from F1 to F2. From F1 to F2, the particular portion of the signal will be passed, and everything before F1 and everything after F2 will be blocked, right? Only the middle portion will be the pass. Only middle portion will be pass. Now in this band pass filter, we have two types. That is, one is wide band and the other one is narrow band. What do you understand by this term wide band and narrow band? It's very simple. Wide band means the bandwidth will be wide. Bandwidth will be wide means the gap between f1 and f2 will be large. Gap between f1 and f2 will be large in wide band, whereas in narrow band the gap will be very narrow. The gap between f1 and f2 will be very narrow. Just see the diagram. The first one is representing wide band and the second diagram is representing narrow band. Just compare these two diagrams. Compare these two. So there you can see F1, the gap between F1 and F2 is very wide, whereas here the gap between F1 and F2 is very short, very narrow. And at the center you can also notice another frequency F0. F0 we call it a center frequency, center mark. Okay, the center point of F1 and F2 is F0. Okay, so what do you understand by the term bandwidth? Bandwidth of the filter circuit is given by F2 minus F1. F2 minus F1. There is a new factor called as Q factor. Do you see here? Q equal to 1, Q equal to 10. What is this Q? Q factor is a figure of merit for the filter circuit, which shows that uh, how selective the filter is in passing the center frequency and rejecting all other frequencies. Means how well it can choose the F0, how well it can recognize and stick with F0 frequency, that is center frequency. So Q is given by F0 divided by B, where F0 is center frequency, B is the bandwidth. Okay. So to calculate F0, you can do like this: root of F1 into F2 will give you F0. Okay. Well, now let us see the design for narrow band pass filter. Wide band, okay, wide band pass filter is same like what we have seen yesterday. It is this. This is wide band. This is wide band filter. Wide band pass filter. Same circuit is slightly modified here for the narrow band pass filter. The modification is that R4 is added. Rest all things are same as previous. Rest all things are same as your band pass filter. To make it narrow band pass filter, the only element added is R4. Okay. Yeah, see, additional resistance R4 brings the cutoff frequency F1 and F2 closer. What does it mean? By adding resistor R4 into your circuit in this way as shown above, will bring your F1 and F2 very closer here in this frequency response. In this frequency response, F1 and F2 will come very close to each other. So this makes the response very narrow. This makes the response very narrow. That is the purpose of adding R4. So design part, if we see C1 equal to C2 equal to C, we have seen this. We may require to assume capacitance here. R1 equal to half of R2 and R2 is equal to 2QC 2Q XC at F0. So since a new frequency is coming into picture here, F0, you know how to calculate F0. So therefore R4 is calculated as R1 divided by 2Q square minus 1. Okay. Directly the equations are given, much detailed design is not required. Okay. So just let us have one problem here. Using 741 opamp, design a band pass filter. The center frequency is to be 1 kilohertz and the pass band is to be approximately plus or minus 33 hertz, plus or minus 33 hertz on each side of 1 kilohertz. on each side of 1 kilohertz. Means 1 kilohertz is our center frequency. Before 1 kilohertz minus 130 minus 1 minus 33 hertz, and after 1 kilohertz plus 33 hertz. Okay. So bandwidth, how will you calculate? F2 minus F1. F2 is plus 33, F1 is minus 33. Minus into minus plus. So minus of minus plus, so 33 plus 33, 66 hertz is the bandwidth. Okay, don't make 33 minus 33 0 hertz, that will be wrong. Okay, bandwidth is the gap between F1 and F2. Hence Q equal to F naught by B, which will give you 15.2. Then R2 you have to calculate as the given formula. R2 equal to R3, C equal to 2Q, this formula is given to you. With this you can calculate capacitance C, which is also equal for C1 as well as C2, right? Finally you have to calculate R4 value. It is coming out to be 130 ohms. Just go through this problem. Okay, it's better if you draw the circuit diagram. Always remember to draw circuit diagram before solving problem, because you won't be understanding where is R1, where is R2, R3, C, all that. The more you draw, the more you remember. The more you draw, that will be a practice for you for your exams. Next, band stop filter and band reject filter. Actually this is not the part of your syllabus. Okay, it's not there in your syllabus. Earlier it used to be there. As per your syllabus you have only band pass filter and all pass filter. Band pass filter and all pass filter. So band stop filter is not there for you. Okay, so let us skip this. Now let us see this problem. Design a wide band pass filter having FL equal to 400 Hz, FH equal to 2 kilohertz, and pass band gain of 4. It's important problem. Just concentrate here, all of you. This is what the band pass filter diagram is. You need to remember. Okay. FL is 400 given, FH is 2 kilo, and AV is equal to 4. See, we haven't solved a problem where the gain is 4 or anything other than 1. In this case we have a gain of 4. So let us solve a problem which has a gain other than 1. So assume capacitance 1000 picofarads, XC2 equal to R2 at FH. So for this you will be using the design of band pass filter, not the narrow band pass filter. You will be using wide band filter. So you don't have F0 here. There will not be any F0. Okay. So don't get confused with wide band pass filter and narrow band pass filter. F0 comes only in narrow band pass filter. Okay. So you will be getting R2 value here as 79.57K, which is nothing but approximately 80K. R2 is coming out to be 80K, and the gain is equal to 4. And we know that the input for the circuit is applied where? To inverting terminal. Inverting terminal gain, how it is given? Feedback resistance by input resistance, isn't it? AV is equal to R2 by R1. AV is equal to R2 by R1, feedback resistance by input resistance, which is nothing but equal to 4. We have already calculated R2 equal to 80 kilo ohms, right? 79 nothing but 80 kilo ohms. So approximately what will be the value of R1? R1 value will be R2 by 4. R2 by 4. So if you do 80 by 4, it is coming around 20 kilo ohms. So R1 will be 20 kilo ohms to satisfy AV equal to 4. To satisfy pass band gain equal to 4. Therefore, this is how you can calculate capacitance C1. You will get 0.19 microfarad. Okay. There is another problem here. Why this became ulta? I am finding it difficult to explain. Design a first order low pass filter with a cutoff frequency of 1 kilohertz and pass band gain of 2. So this problem is very important. All of you go through this. It's very simple. Passband gain of 2 means nothing but AV equal to 1 plus R2 by R3, because this input is given to low pass filter, right? Input is given to non-inverting terminal. Gain will be 1 plus R2 by R3. 1 plus feedback resistance by input resistance equal to 2, which is nothing but 1 plus 1 equal to 2, right? It means R2 by R3 should be equal to 1. Therefore, R2 should be equal to R3. Go through this problem. You have same thing in your notes. Okay. So let me end here and let me have another video for all pass filter.